Okay, in this video, I will show you how to solve this problem. Develop a program to adjust the duty cycle of timer 3, channel 1, PA6 uh, by varying a preset value, a preset blue potentiometer within the range of 0 to 60%. The duty cycle should be displayed on the multi-7 segment display in the format of xx.yy, where xx represent the two-digit integer part and yy represent the fractional part. The point, the decimal point, the decimal point of that integer. Ensure the other latch connected to PA5, PA7, and PB6 are disabled. Okay, wait, don't touch it. Right? Don't touch it. Not utilize the timer in time-based mode to multiplex the 7-segment display. Okay, so we will use another timer 11, for example, in this case, right, for 7-segment display. Using an analog input, okay, from presets, with a voltage range of 0 to 3.3 volt. Of course, the voltage is from 0 to 3.3 volt. And configuring the ADC to 10-bit resolution, the input range is mapped from 0 to 1023. So everyone knows. The timer is configured in PWM mode with a period of 10,000 to achieve a PWM frequency of 1 kHz. Okay, this is the what we are setting. Right? You can set it to 1,000, up to you. The maximum duty cycle is set to 60%, therefore 6,000. And 60% of 10,000 is 60,000. Hence, the ADC input contribution to the timer pulse is equal to ADC in digital divided by 1023, the maximum input of the ADC, multiply with 6,000. For example, if the input is 1023, so we got 6,000. If you multiply it with 5.8651, you got 6,000. If the input is, say, half of it, 511, multiply with it 5.8651, you got about 3,000, right? So that's his value that will be fit to the timer pulse, right? Timer pulse. Alright, and the duty cycle percentage, right, actually when we talk about the percentage, right? So the pulse, 6,000 for example, divide by 10,000, right? The maximum, which is the period, right? Which is the period of the timer, and multiply with 100,000. Okay, so we got that pulse over 100, right? Pulse over 100, 1, 2, 1, 2, yeah, pulse over 100%. So whatever the value that we calculate here, just divide it with 100, then we got the duty cycle. If you want to display it on the serial port, for example, right? For the serial port, for example. But if you want to display it on the 7 segments with 2 decimal point, right? Two decimal places or decimal point. So what we need to do is multiply with 100. So when we pulse, right? So duty cycle is pulse over 100%, pulse over 100%, multiply by 100. So divide it, then you got pulse. So the duty cycle is the pulse. So we will send it directly to the multi-segment later on, right? Okay, 6,000. Okay, that's all for that. So we go to the remember that we have 2 timer here. So the first timer we set for PA6, right? PA6. You can click this one first to channel 1, right? Then go to the timer. But before that, better we go to the frequency and the clock frequency. Say we set this one to 60 meg, alright? Okay. So see here, the APB2 timer is 60, and APB1 timer also is 60. Remember that timer 3 is connected to APB1, right? So 60 meg, okay? Okay. Alright. So setting up the FPWM, this one, to 1 meg, 1K, 1 exponent 3. setting this one FPBX to 60 meg, right? And then adjust the divisor, and remember to set PR to 10,000, right? To 10,000, because we stated that we want the PR to be 10,000. So we have the PS of 6, right? So if you choose this one to 4, it's okay, but I think this time I will set it to 1, right? It's up to us. Okay, so go back to the pinout configuration, timer 3, right? Channel 1, right? Because we use channel 1 here. So we can set the internal clock, right? That one to internal clock, okay. Then set this one to preload generations at channel 1, right? Channel 1, so it comes out right, like that. So you can see it. So what we can do here, we can set the parameter setting, right? The parameters, right? We can do the parameter setting. Okay, now the prescaler is 10,000. Is 4, or 4, 6, I think 6, and prescaler 6 minus 1, again 6 minus 1, then counter mode is up, the period is 10,000, okay, we set it to 10,000, enter. Okay, no divisions because we select 1. Auto reload, we enable it, okay. Then master slave disable, reset UG, okay, we can set reset UG, but we not use it, right? We will set it directly. And then the mode, preload mode 1, see, we select preload 1. And then the pulse, let it to 0, output compare, preload, enable, pass mode disable, and then the polarity, with the polarity, we set it to low, because our LED is active low, right? Polarity to low, else it will inverted. Okay, and then you can set the NBIC if you like, enable it, right? Maybe you can do it. Okay. No, say no for time being. Later we go to timer 11, right? Timer 11, activate. Next we go to the for that, right, 60 time delay. We want same, so PS 40 and then PR of 40, right? So we can set that one to parameters, right? So we can set to PS of 60, I think 6,000. Yeah, PS of 6,000. This one. And this one. Then up. Then this one we set to 40, right? 40 there. So 40 minus 1. Then no divisions. Yes, no divisions. Because we set to okay, divide by 1. Then disable, set to enable. That's all for that. And don't forget to enable the NBIC for timer 11. Okay, these two already set. Then we go to analog ADC. We need in 0 here. Then parameters, independent mode, right? Independent mode. Say we want to change it is okay. So that is ADC. So see the ADC here is where okay, this one, right? Say we set it to 10 to 10 micro. To 10 micro, divisor of 8, 60, right? This one 60,000. Okay, remember our PCL2 here. This one PCL2 is 60. Next, and then divide by okay. What is the divisor here is 8. Okay, you can set it to 2 if you like. What the sampling is greater. I think we don't have this value. I think. Set. Yeah, we have it, right? But it's too big, right? Okay, so we set it to 1, 4, 137, 137. Okay, 144 we have here. 144. Alright, so we accept the device to 4. Alright, so 10 bit, yeah, resolution. Divide by 2, PCL divide by 4, divided by 4, right alignment, correct, disable, and of conversions plug, single channel because we use ADC, remember, not DMA. Then number of conversion is 1, okay, number of conversion is 1. External trigger conversion, no. Regular conversions launched by software. Rank 1 channel is 144, right? 144 because here is 137. Okay, so again, 10 bit, right alignment, disable, and of conversion flag at the end of single channel. Regular conversion launched by software, none, rank 1, channel 0, 144 cycle. Others, no need. Then go to the NBIC and then enable it. That's all for that, right? That's all. Okay, then before that we need to set the PA8, PA9, all that 3, and the last one is PB5, all to the pushful, right? All to pushful. Okay, no need to, actually no need for you to check it, right? Because by default it's already pushful, right? And then no other things, I think. Yeah, we set already our ADC, we set already our timer, right? If you need the to check your code, right, using the serial port, just go to user2, and then enable it, right? And then write code accordingly. Okay, then generate code. Okay, you have that. Okay, next, what we do, we add the driver that we need. So the first driver that we need is multi-learning. Okay, we move multi-learning, okay, and then user tick, move that, right? Move to source.c. Okay, that's all. Okay, then include them. First found inc, go to space, double quote, user tick, enter, found inc, go to space, double quote, multi mul, go to space. We include both of them. Then now we can go to the code, right? Code. So the first code that we do have is to maybe, right? We can go to the right. We can go to enable the analog, right? Yeah. Okay, we set 66 save 2. Then after that, in the code, we say if get 66 number 1 is 0, each 50 millisecond, right? If 50 milliseconds, say, or if at 100 millisecond, then we start the ADC, IT, yeah, because we enable it in IT, so we read it, right? Then when we call it, then it will interrupt it, right? It will interrupt it. So we need a callback. Click callback, find ADC. From the list outline here, we can have ADC convert complete, right? Right? Line 1580, copy that one, this one only, copy, and place it in the main, place it here, enter, right? And now we write a code inside it. So whenever this is converted, then we can write code. Okay, so we write code now. So if so you are int 16 again, you are int 16 because 10 bit, name it as digital value. Okay, I love to name it digital value. Then we use the whole ADC API to get value. So the get value from that handler, right? So we have it. So later we can apply it, right? We can calculate the pulse, right? So whatever that we get, we can calculate it. So we're going to multiply it with this value to get pulse. So we can name, say, double, and pulse is equal to, right? We multiply the digital value, right? We multiply with that, right? But we need to typecast, right? Typecast that one, the digital value into double. But before that, we can stop HAL underscore ADC underscore stop, control IT, right? HADC, stop it, right? Because it's converted already. Then we have the value here, right? Double pulse. Okay, so this one we can push to our what we call. So that is the value that we have. Then we can push it into our timer, right? If you okay, right. Next, what we do is, yeah, we can push it directly to our timer. So we can write down, let's say, TIM, and but before that we need to enable, right, timer. Okay, we stop there for time being. Now we go to the second one, right? The second one for our display, right? We self the display first. So in the display, we need to HAL underscore TIM underscore start. Oh, time base or start. We need to start IT STM11, right? STM11. We're not going the UG part or the timer interrupt flag for the STM3, so we use STM11 only for this case, right? So whenever it is so now we go to the 7 segment on off on the segment. We can copy this one faster. On all segment, right? Then after that, you can display your duty cycle. So we have the duty cycle. The pulse will go to, okay, double pulse, blah 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 blah. Okay, so this pulse, I would what recommend it to be put here, right? So it's equal to 0, for example, right? So this is a pulse, right? So we can make use them that pulse, right? We can make use that pulse here. So what we do, we can call that convert that pulse, but that pulse is in double. We need to change it to UINT 16, right? Okay, pulse. Okay, convert to sample element. Then okay, so we need to have another thing here. Yeah, so what we need, the timer, called by. So we need to find the period elapse, right? Period elapse here. Copy this one only, right? Go to the main. Okay, so we place it here, right? Enter. So each time it is if that HTML instance is from that TIM11, right? Then we will call the multiply the segment. So we multiply the segment. That's all the code there. right? So we complete that one. Okay. Next, we need to go to the HAL underscore team underscore PWM, right? To start it. Start. Okay, we have to start IT. So as team the 3 channel, team underscore channel 3 as 1, sorry, right? Then we can straightly push the value inside that 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 pulse, right? That pulse, right? By type team 3 channel CCR 1, channel 1 should be equal to UINT16 pulse, right? UINT16 pulse. Remember, it is because the timer channel here, you will see at the parameters here, it is 16 bit, right? It is 16 bit. Yeah, 16 bit value, right? This 16 bit value, right? Pulse, 16 bit value. So you cannot put a double inside it. Okay. Okay, right. Pulse. Okay. That's settled. Then after that, you can HAL team base start IT ST11. Yeah, okay. Then you can copy this one, right? Then each time it is okay. So that is the value of the what we call uh, the PWM. Right? This is inside your duty cycle for your PWM. But as you want to change your your pulse, right? Okay. So actually the value here, right? When you see here, okay. So this is the duty cycle, right? That we want to place, right? To the 7 segment, right? To the 7 segment. Okay. The modified duty cycle percentage expressed in 2 decimal place integer representation will be. So we need to multiply further with 100, right? Multiply further with 100. Maybe you can do it here, right? Another one, right? So maybe we can use another yeah, another say whatever. Okay, you can leave it there, or you can use something else. Okay, double duty cycle, right? To display, just put to 0. So I'm sorry, this is actually the one that we want to display here, right? This is the one. Okay, so all right, now we can use that one duty cycle. Okay, it is double, so we need to no problem, yes, because pulse already changed in double, so you can multiply it with 100, right? So equal to pulse multiply with 100. Okay, you got it. Now then you can call the what we call this one. I'm this sorry, this one I make wrong. This one salah. So this one duty cycle. See, the one that we want to display is the duty cycle here. This one, okay, the present duty cycle. So the duty cycle is the as it's in double, so we typecast it to UNT16. Remember, I put it here because I want it to be used in the main and also in there. Okay, actually this one no need for you to display this one and this one too, right? Because no need, no need, because it's very fast, right? The code is very fast, so you cannot see that lagging. But if you want to ensure that you see zero when it started, then better you call, okay, you call that convert number to 7 segment, because this convert number to 7 segment, when it's converted, then the data, the string, no, sorry, the array will be used by the multiplex segment here, right? But will be used by the multiplex segment here. Okay, so I show you again the code. First, on off the segment, so we're going to on all the segment. Then we convert the duty cycle to 7 segment, right? The presentation, and yeah, by passing that duty cycle, which is in double, but typecast to UNT16. So when it's displayed there, we can see that duty cycle, say we set it to 100, so we can see 100 there. And then whole team PWM start IT STM11 channel. This is to enable the PWM for channel 1, timer 3. Then after that, then we set it to the pulse. Pulse is 0, so we clear it to 0. And then whole team base start IT HTM11. This one is to start the time base timer 11. Right? Then we use a set stick. This one, right? we use one only. Okay, so each 100 millisecond, then we will call or trigger the ADC. So when ADC is triggered, is interrupted, then what we do, then we calculate and we get the value into, and then from that, then we stop the ADC. Then we calculate the pulse. So the pulse is whatever the one that we read, the pulse, whatever that we read here, digital, we multiply with the constant here. Constant is 5.89651. Okay. Then after that, then we feed it to the pulse, to the PWM for duty cycle. Right? For the period for the pulse width, pulse width. And then we calculate the duty cycle to be represents actually the one we multiply by 100, yeah, by 100, yeah. Right? Yeah, sorry, duty cycle equal to pulse, yeah, pulse. Oh, no need, right? No need. Wait. Okay, no need, sorry, no need to show whatever the pulse that we got here, right? Actually, that one is the one that we're going to display, right? So okay, so that is the one that, right, that we're going to display. Again, I check again. So the first one we multiply whatever that we read with 58651 to get the pulse. Yeah. So that is the pulse. Okay. Then from here, so we whatever the pulse that we have, we divide by 10,000 to get the percent. We multiply by 100, so we got 100%. So pulse rate by 100, we got percent. But when to display it with 2 decimal point, we multiply again with 100. So whatever pulse is duty cycle, right? So duty cycle equal to pulse, and then we convert that into 77 display, and display it there, right? This is nothing, just each 4 millisecond update the 7 segment. Okay, that's all the code. I think it's very simple. Okay, again I show you the code. Okay, and then here, right? And finally we go to uh, the multi-segment. Okay, to the multi-segment display. We go here to the first, we don't want the leading zero, command 8, right? That's all for that. Then we modify a bit the code in multi-segments.c, because okay, if you look at the 7 segment here, we have 1, 2, 3, 4. Now we want the dot here, we want the dot here, not here. Okay, so with the dot is here. So this is 0, this is 1. So when I equal to 1, okay, so what we do, okay, when I equal to 1, then we need to modify the code. So copy bit here, then type here in if I is equal to 0, then okay, then we end and all that, this one we end with 080000, 8,000, right? This is, so that one will become 0111 1111 1111 and 1111. So this one will on the dot, the dot for this segment. Which segment? Segment 1, segment 1. Else, right? Else we do receive. So that means no dot, right? No dot. Okay. So if you have no problem there, okay, what we can do now, you can compile and check if there is any problem and download it. All right, that's all. Bye bye.